Let's now look at how to solve an equation that involves a log. So in this case, we've got log base 3 of 4x minus 7 equals 2. Well, let's start off by converting this to exponential form. So base 3 to the exponent 2 would be 3 squared equals 4x minus 7. And let's simplify 3 squared is 9 equals 4x minus 7. And all of a sudden this equation looks a whole lot easier than it did just 2 steps ago. So let's see, add 7 to both sides, we get 16 equals 4x. Divide both sides by 4, and we get 4 equals x. If we plug that back into the original equation, we get 4 times 4 is 16 minus 7 would be a 9 here, and we know in fact that 3 squared is equal to 9, so our value checks out. Now let's try a problem where the variable occurs in the base, but we'll solve it just like we did a minute ago. So convert it to exponential form, so base x with a 2 exponent equals 64, so x squared equals 64. If we take the square root of both sides, we get x equals plus or minus the square root of 64, which is 8. So this means that x is equal to 8, or x is equal to negative 8. But recall back to our definition for logarithms, we can't have a log base negative 8. So this is not allowable according to our definition of logarithms. Refer to the definition on this page if you need a reminder. So that means our only possible answer is x equals 8, and if we plug it in, we see that in fact 8 squared equals 64. That works out. In the case of log 1000 equals x, keep in mind that if we don't specify a base, that base is 10. So we could think of this as being log base 10 of 1000 equals x. And when we write this in exponential form, we'd get 10 to the x equals 1000. Write both sides in terms of the same base. 10 to the x equals 10 cubed. So x equals 3. For equations with natural logs, we follow the exact same steps. So keep in mind that this is really the log base e to the x equals 7. So when we convert this to exponential form, we get e to the 7th equals e to the x. So 7 equals x.